Milk is a huge part of most people's diets across the world, especially in the United States. We are born to develop and grow on an all-milk diet from infancy until we reach a certain age, and many adults continue to drink milk throughout their lives, specifically cow's milk. Milk is found everywhere, in supermarkets, restaurants, and homes. Milk from animals contains many nutrients that are difficult to obtain in non-dairy foods and are also a good source of protein. Milk promotes skeletal health as well. Because this nutritious food product is so commonly consumed, we have decided to analyze the nutrient content of two different types of Oak Farms dairy milk, whole and non-fat milk. We were interested to see if the processing of non-fat milk would result in differences in nutrient composition compared to whole milk. Skim milk is milk with all the cream removed, which means over 99.5% of the fat is gone. This makes the milk virtually fat-free, and the two terms skim and non-fat are used interchangeably. The process of skimming whole milk involves removing fat globules, and this results in a loss of nutrients and a denaturing of various proteins. This is why non-fat milk has to be fortified with vitamin A, which is lost when the fat is removed. Non-fat milk is also lower in calories than other types of milk, which is one of its appeals for diet-conscious individuals. Whole milk, on the other hand, retains all of the fat of cow's milk, and because it does not undergo additional processing that non-fat milk goes through, it could retain more nutrients than non-fat milk. Our project focuses on determining the contents of calcium, copper, and vitamin A in Oak Farms dairy whole and non-fat milk using two different methods to see whether or not the actual contents of the milk matches the nutrition facts labels or the USDA nutrient database, and whether or not there is a nutritional difference between the two. Our results showed that the amount of calcium found in non-fat and whole milk are not significantly different from the value on the label. However, for vitamin A, the amount found in the two milks was much greater than the amount on the label. Non-fat had approximately 10 times more vitamin A than the label indicated, and whole milk had approximately 5 times more vitamin A. Lastly, copper was the most shocking, being almost 8 times higher than the value on the USDA nutrient database for non-fat and 10 times higher for whole milk. These results are important because as little as 10 milligrams of copper a day can have harmful effects on the body, such as vomiting, bloody diarrhea, fever, stomach pain, low blood pressure, anemia, and heart problems. Additionally, high doses of vitamin A can cause dry, scaly skin, fatigue, bone and joint pains, and headaches. A possible source of error for the copper experiment would be using a compound that was perhaps impure. This would cause our results to significantly vary. Also, for the vitamin A experiment, we did not follow the protocol verbatim, and this could have a negative impact on our results as well. Overall, we were somewhat puzzled but also satisfied by our results, and we had an exceptional time analyzing the contents in whole and non-fat milk.